we were trying to fix this problem. So now the user gets his desired values, of course, and then he also gets a clean message to him saying that okay, enter only numbers. Now he knows exactly that okay, this calculator supports only numbers. So now he will change his input and change this value. So in fact, if the requirement was to support the text as an input, what you should write is maybe you import a library or write your own code to convert A and B A and B into something like convert text to numbers, something like that. So you can write a function something like this, convert text to numbers, and then pass that particular text and convert that as number. So either you can write that, depends on the requirement. So here the requirement is simple. So allow user only to enter numbers. So the main problem was the program was stopping abruptly, and then it is not doing all the other things that was below it. So that was the major problem. So we have added 3 test cases, 1, 2 and 3 test cases. So what else can go wrong? So maybe in future, maybe the program has grown big, and now it is possible that that particular software, that is your calculator, maybe it is being used in a supermarket. So in supermarket, what is happening? Instead of text, there is a input from picture. That means there is a scanner, and it scans the price, and then instead of the number, what you get is you get a image name or binary coded image. So something like this image name, okay, dot some jpg, or maybe you're getting a bitmap or something like that. So let us for simplicity, let us think that it's a file name. Okay, so image.jpg. okay, so once you have this then what is the problem? Again, you have to change this particular code and write a lot of code to use this image and convert that into a different format, that is integer format or a number format. So now you see that we started with a single line of code, and the code has grown to about 8 lines. So if you keep writing it into a larger test cases, the code will also grow. So if you had to implement these two functions, maybe the code has grown to maybe 500 lines or 600 lines, whatever it is. Okay, so from this simple program, now it has grown to a bigger program. Now it is really difficult to test whether now the person who is writing code for parsing this image and then getting the number, so he will write a function and call it here somewhere, and then what happens is that okay, that image is working. That means the input from the image is working. Maybe he has done something, then the user tries to calculate this first one, then that is not working. So okay, the features which are new features are working, but the old feature is not working. That means this is called as regression. So regression, the old features are called as in test scenario, it is called as a regression. That means without breaking old features, you have to implement new features. So how to make sure? So since we are doing it manually here, how do you make sure that it is automatically tested for maybe every check-in? So every change that a developer does, there should be some automated kind of way to verify all these things. So let us try to, I'll remove these 2 lines of code because we are not going to take image. Okay, so what I'm going to do is so these are my basic 3 test cases, and test cases has grown till here. I'm going to try to do a manual verification. So that we did, and then we can do automated verification. How do we do automated verification? So let us just for simplicity, let us take the same program and call it as test file. Okay, calculate, same program. I'll, instead of now in the code has not gone into customer place, it is still in the development level phase. So I'm going to create a file called as calculate test, and the intention of this program is to test my program. Okay, so it has not now let us rewind back. It has not gone into customer place. It is still in the development level test. So now there are maybe there are two people working, there is a team working. So what the first thing what we do is we try to make a list of all the input that can possibly go into the function. So it can be okay, for first test case is simple. It can be numbers, fine. It can be negative numbers, that is fine. The third test case is it can be one of them can be number and another can be a text. So if I start writing tests further, so I can even tell that instead of numbers, instead of coming it as a text, maybe it is coming as a string, but it is a number. So this is also one more test case. So similarly, I can keep on writing test cases like this. So I can write something like 400, 300. Okay. So all these are valid test cases. So these are the inputs. So in fact, you can write more, but I'll just stop it here. So how do I automatically test this? So once I run this program, my expectation is okay, that file is no more there. So my expectation is this. Okay, when I add these two numbers, my expectation is 57,000. So I write that expectation like this: if money is equal to 57,000, print okay, else not okay. So let us just do that. Now it is okay, it's just 5,700. So I'll just make it right. Okay. Now we are getting, so let us just take away this print statement. Now it is telling that okay, this test case is okay. So what we are trying to do it now, we are automating it. So I am automating the test cases using if else conditions. So I know the exact inputs. So for these exact inputs, so now I am going to check in this file, and for every change that is made here, say for example I'll make some change here, say instead of returning sum, I'll make something like buffer is equal to 0. Maybe this buffer is for some rounding off purpose. So I'll just add, so forget about the logic. So maybe there is a buffer of so I'm adding a buffer to sum. So even after doing this this one changes, I should make sure that my test cases are still working fine according to the requirement. So now I manually ran this test case, but usually this will be so somewhere put inside your automation system, something like Jenkins or your code level. Even in fact in Git you can add commit hooks so that once you commit something, the test cases are automatically run. So such automation is possible. So now we have simply automated the value. So now even if I have changed it here, since one person is changing it, it looks like one person is changing it. But in fact, imagine that the old program was changed by one person. This program is changed by another person. So that guy is not worried about this test case. So maybe he writes his own test case for buffer, and then he will finish it off. And then for him, but for the entire program, that is the entire software, it is important to make sure that the old ones are working. So now we have written if else condition. So if you start writing if else condition, what is the problem? The problem is this code can grow really big, and on top of this I need additional reports. For example, I need how many test cases are running, and I need to maybe disable some test cases or run only few test cases. So all this kind of dynamics comes into picture once you have a list of test cases. So first thing is to get the list of test cases. Okay, that headache is gone. So next level is we were testing manually, now we have automated it. So now that headache is gone. Now there is a new headache. That means say for example, my new features are coming in, but it only works if there is some special inputs. So I need to disable some test cases only for to make sure that this is working. So in such cases, maybe you need a feature to disable this. So if you had to manually disable this, then you had to like comment this code, and also maybe you in your report, maybe you also need test case name. So if you had to write test case name, so if you had to do it manually, I will write a function something like test simple add, and then give a test name here, something like print test name as something like that. So inside this I'll write all this, I'll move all this code something like this. So I will execute these functions in one more function. So now you have test case names and all this level of control. Now you can see the list of test case, what are running and all these things. Now next level is so why do you need to do all these things by yourself? So in order to understand, I was telling about all the problems, but there are libraries which does this for you. So that library is called as unit testing. So let us just try to learn about unit test. Give me a moment. Let us simply learn about unit tests. Okay. Let us look at the syntax and things like that. Okay. So all these libraries are written by people who have found this problem again and again. So for example, last time we saw regular expression, it's a recurring problem, and there is a library. So this unit test is much more has much more control than our we are writing our own functions and we are writing if else conditions. So in fact you can you can skip this if else condition, and there is also a keyword called as assert. Okay, and then what assert does is it simply validates its if it is true or false. Okay, so let us make this as let us try to fail this. Okay, so how it looks. So this is a test file. Now it says that okay, assertion error, that means this is not equal to, so it stops all the program. So this is expected in while writing test cases. It is better that the program stops, because this is a test program and it has to stop and it has to tell me what has gone wrong. So if it simply if we handle error here, what happens is it executes all of this and it gives a false notion of that of the problems, that okay, every other test case is failing or passing. Okay, so it is important to fail the test case. So that failing is done by assert. So in test files, it is important to stop the test suite. So here we have stopped the test suite. So here what we have automated if else condition. So if it is true, only then simply keep going. If it is false, throw a error. So that level of automation is possible. Now let us, all these features can be done using unit tests. So this is the basic example. This is how you need to learn about new libraries. So take this code, let us use the same code into our code, and let us see how things work. Okay, so let me try to remove this stuff. Hmm. 24, 10, 13. Okay, 13 lines. So I'm going to move this code here. And then I'm going to put this in. These are my test cases, and I'm going to write tests for this. So how do I write tests? It is quite simple. You write a function, something like what you're testing. So it is important that you start the test case with test underscore. Okay, so we will see why it is like that. And what are we doing here? Test simple. It is like it is like a test case name. So what you do is you write it in a way that it is readable and it is understandable. So simple add integers. So here, since we are passing integers, so I'll just keep it as integers. So I am writing self inside this function. That is because this is a member function of a certain class. So we will see this in a moment. Test simple calc. Okay. We'll see the structure in a moment. So what I'm trying to do, so I have developed from basic if-else conditions to assert, and then I'm trying to move it to test cases to realize what is the advantage of this unit test framework. So I'm going to write, I just use the same code, and then I'm going to write few more test cases. So I'm going to move this here. I'm going to change the names, so I'm just making it look nice. Okay, so these are my test cases. So once I have these test cases, okay, let me just remove these two lines. So let me have only those test cases, and let me take this asset and put it here and modify it. So this is how you need to learn to adapt to code that is existing. So take the code and then modify it. So it's not it is not necessary, and it is actually it is time consuming, and it is your end goal is to make it work. So it is like taking different pieces of clothes and then you're stitching something. So your end goal is to prepare the cloth. It's not to make your own clothes and then stitch it. Okay, so use the code that is available and modify it and try to stitch it. So this is what I am trying to do it here. So what I'm trying to do, I'm trying to stitch the code. So how am I stitching? So I took the code and then I wrote my own code here. So I have moved from that. So now I need to make some changes here. So it is not assert equal and this these numbers. So this should be equal to something like money should be equal to, oh, why is my keyboard acting so slow, 57,000. Okay, so similarly I'm going to add, what was the number here? It was 19512. So I'm going to just use the same code. So I'm going to do it only for these two values for now, because it's going to take some time. My keyboard has become very slow. Okay, so now I have two test cases which are here. So I'm just going to comment this asset because it's going to take some time. Okay, test cases, and let me see if there are any more test cases. Okay, that's all. What is this character? All right, so what have I done here? Let us go back to unit test. So the syntax is simple. You import a library called as unit test. So why this library? That is because you can write your own code to do all these things, but this pattern is repeating, and that is why the people around the world have written the code to do this. So this is one of the popular libraries. There are other libraries as well. You can try out that. This is part of the Python installation that you have already done. So the good libraries get into the Python installation. So if people are using it from many years, it gets into the library, Python default libraries. So what is happening? So you declare a simple class about classes we have studied yesterday, and then we inherit a class from unit test. So yesterday we saw that we are inheriting from animal to make mammal. So similarly, so there is a class already defined inside unit test. So that class can be accessed like this: unit test dot test case, and then all the characteristics inside that unit test case is now available to your code. So this is your code. Okay, so now let us get back to our code. Let us look at what's happening. Are there any mistakes? Method alerts. Okay, I need to change the test case names. So this is simple add integers, add int, and negative. So I'm giving names in such a way that it is understandable. Okay. And then this is add integer text. So that is about that function, and this takes integer and text, something like this. Okay, so these function names are different, and these act as our test case names. So how do we execute that? Python -m unit test. -m is for modules. You can, it's like giving .so in C++ while making library. So while executing, you give that .so. So you're just specifying the library. So that is the syntax, and then Python use this unit test library and then run this particular file. So this is our test file. So let me try to run that. Let me see what is happening. Awesome. Now you can see that the program has run, and it is giving some kind of statistics. So it is telling that it ran 4 test cases in this many seconds, and it is okay. So let us try to fail one of the test cases. I'll just fail this. first test case and look at how it looks. Now you can see that it is telling that ran 4 test cases in this much of time, and there is one failure, and it fails abruptly. That means it doesn't execute the statements which gets executed after that. So what is the test case that has failed? It is telling that test underscore simple add integers from this class is failing. So this is the test case name. Test case name is nothing but the function name, and what is failing? This assert equal to is failing. So we saw that instead of doing it manually, it is much more simpler to simply write inherit. So you don't have to write all this code to do the statistics and all this stuff. What you do is you inherit the code from your test case and simply write simple functions which are nothing but test cases, and it takes it doesn't execute in the same order. It takes randomly, and I think it takes in alphabetical order or something like that. So write the test cases. So it doesn't matter because your order doesn't matter, but in case you need to write it in order, there is a way. So you can search that and do it in fact, or you can call that function inside another function, so in order to make it order. But you have test cases and this get executed. So while executing, you get a lot of statistics, and this can be since we are seeing it on a monitor, that is fine. And you can also do it, you can generate reports from HTML, and then you can generate reports in XML, and you can send that maybe XML reports or HTML reports to people who have written this code. Say for example, so we were writing code here. So once this is our actual code, so this is our test code which tests this. You can see that this is only what, 11 lines, 10 lines. So look at this. This guy is like 25 lines already. So you can write more cases, and then the test code is actually bigger than your production code. That means your actual code. Why is it so? Because you are trying to verify a lot of things. So that is how important the unit test case is. Now imagine that in our first example, so instead of spending losing crores, so now you are simply writing tests, and for every test, for every check-in, this runs and gives us the report. And if it is okay, so once you see this is okay, then you see that okay, the test cases are running fine, even my old features are working fine. So now you can deploy things to production. So this will give control in terms of quality, in terms of code confidence, and all your team is happy. So if you didn't have this file which is testing this feature, so imagine your level of confidence will be like almost zero, because only few test cases that you manually verified is working, but I don't know other inputs. So you can simply give -v and see what are all the test cases names as well. So that is verbose mode. So this is like okay, this is one test case simple add in a negative integer. So this is one test case, and it lists the test case. So these are the features, and then there are several other features in unit test. This is the basic feature, and then you can generate HTMLs and send it via mails. It will be much more nicer for managers or people who do not know what is happening in the code. They can look list of test cases and see what is failing, and immediately alert the team. Okay, so such things are done in unit test cases. Okay. So this is how powerful it is, and it is important that you test your code before it goes into production. So that is I had about unit test cases. So if you have any questions, you can ask. So in fact, you can simply show the code and tell the syntax and how it works. So I didn't want to do that. So I wanted to first write, bring up the necessity. So if you understand why we are doing this and why we are using the library, once you have that in mind, you won't forget this. Or else what happens is you will read the syntax and you think that kahin pe padha tha, then you will think that okay, this is how it works. But if you know why it works and why it is necessary, then you won't forget, and it is always there in your mind. So in order to test this code, first level what we did, we write our own functions here, and then we wrote if else conditions to verify it. So it was crude and it is unmanageable. Then we thought, okay, it should be in a manageable way. We need to have a proper reports and things like that. Then we moved to libraries. So since there are already libraries, we used one of them. Okay, so this is how it looks neat and nice. So that is about unit tests. Okay, so if you have any questions, you can ask. I think I forgot to record half of the session. I thought I was recording, but anyways, I will share this recording session as well as previous bootcamp's recording session. It's similar one, so I make use of that. Okay, any questions? Okay, that's all I had. I think okay. This is like ending of the Python. Whatever you have learned, this is like almost all the concepts in Python. Most of the concepts. There are tips and tricks in Python that, anyways, while you are coding, it will come up and you can learn it. But you have learned about a lot of things in last 8 or 9 days. So tomorrow we will study about requirement analysis. So from here our project will start, and you will use all of the things that we have studied so far, and then it will help us to realize that in the code. So logs, packages, maybe regular expressions, exceptions, and we are going to use libraries for JSON, and all these things we are going to use it in our project.